Hey class, Dr. Yeager here again. So if you're reading through chapter 2, you realize it's a sort of an expounding upon the ideas put forth in chapter 1, and it goes through the concepts that I talked about in that second lecture for chapter 1 again, and that's by design. The only way you understand that is to sort of repeat it. And I want to show you what I think students should do to sort of really wrap their heads around these seasonal changes in insolation. Remember that insolation is the measurable amount of heat that happen, or measurable amount of energy that warms a place up on a given day. And every place's insolation on any given day is going to be different. First day of summer here in San Antonio, obviously it's really hot. We're getting lots of insolation here. The North Pole on the same day, it's not going to be nearly as hot. They're not getting nearly as much insolation in that place. And remember that insolation is is determined by three things: your solar declination, meaning where are the sun's rays directly and striking and most efficiently warming the planet; the solar angle, meaning how high in the sky is the sun at noon. The highest it can be is directly overhead, which is 90 degrees. The daylight hours, how many hours is the sun in the sky? These three things, this plus this plus this, equal insolation. Not in a math formula, but these three things are what determine insolation. So what I recommend is that you make yourself a chart. And so you could say on the first day of spring, insolation is, and we'll come back to that one, okay? But on the first day of spring, solar declination is, where are the sun's rays directly striking the earth on the first day of spring? Well, we remember from our discussion last time that is the equator. EQATR. And the equator has a mathematical value. Its mathematical latitude value is 0 degrees. And I don't know how to do the little degree sign, so. And the equator, we don't have to say north or south, do we? Because there's only one equator. So the solar declination on the first day of spring is the equator. The solar angle, now this depends on where you're at. Because if you're at the equator, okay, if you're at the equator and the question we're asking is, where is the sun in the sky at noon? Well, if you're at the equator, the solar declination is at the equator. And if you're like in a city that is right on the equator, someplace like Quito, Chile, Quito, Ecuador. I'm going to lose my geography credentials. If you're right on the equator at noon, the sun is going to be directly overhead. So the sun would be 90 degrees. Now for us here in San Antonio, the sun is going to be, it won't be at 90 degrees because the sun is directly overhead way down at the equator. So the solar angle for us is going to be sort of a middle number, right? It's not going to be 90 degrees. That would be way overhead. The solar angle for us is going to be some sort of middle number. So I actually looked it up, and the actual solar angle on us in San Antonio on the first day of spring is about 43 degrees. So what that means is that if for us, if 90 degrees is straight above us and 0 degrees is directly out at us, right, that would be 1/4 of a sphere. 45 degrees is right in the middle. So on the first day of spring, at noon, the solar angle, and I call it the solar angle, you might see it in some places as the solar elevation. They mean the same thing. That solar angle is right in the middle, just about 43 degrees. Okay, and we know that on the first day of spring, remember on the first day of spring, the first day of fall, that every place on the planet is getting 12 hours of daylight, okay? So we're kind of in the middle with these two things, right? Our solar angle is right in the middle. Our daylight hour is as middle as it can get. And our solar declination is at the equator. So it's not right on top of us, but it's not as far away as it could be. Everything here is kind of in the middle. What's our weather like on the first day of spring? Generalizing here in San Antonio. Yeah, I know there's that one day where it was 95 degrees. But for the most part, it's warm. It's not hot. It's not cold. It's kind of in between. Everything here is, we're like that mama bear. All right, everything here is in the middle. So our insolation on this day is moderate or medium. Okay, so let's go to the first day of summer. Our solar declination on the first day of summer is the Tropic of Cancer, which is 23.5 degrees, and here you've got to say north or south, right? So the Tropic of Cancer is 23.5 degrees to the north. By the way, us here in San Antonio, that's as close as it will, the solar declination will get to us all year round. Okay, so if we use our handy dandy calculator here, we can fill in all the variables, and I will provide you with this link. It's a fun little tool to play with. We can fill in everything and see that our solar elevation or our solar angle on the first day of summer is 79.93, which is really close to 80. So I'm just going to say 80. This is a much bigger number, isn't it? The sun is much, much, much higher in the sky at noon than it is on the first day of winter. So the solar declination is closer to us on the globe, meaning that areas closer to us are being warmed more efficiently on this day. The sun is much higher in the sky. And how many hours of daylight do we have on the first day of summer? You don't have to be exact with it, but it's more than 12, isn't it? I'm just going to estimate and say it's about 14. We're not trying to be terribly precise here because we don't have to be. We're just trying to understand how this works over the course of the year. What's the weather like on the first day of summer? It is hot, man. And so the solar declination is close to us. The solar angle is super high. Hours of daylight, boom, lots of them. The weather's hot. Our insolation is going to be high, very high. Okay, so let's go to the first day of fall now. Now, this should be really easy because on the first day of fall and the first day of spring, everything's exactly the same, or very, very close to the same. So the solar declination on the first day of the fall, you guessed her, it's at the equator. That's 0 degrees. Solar angle for us will be about 43. It may not be exactly the same, but it will be very close to the same. And every place on the planet gets 12 hours of daylight. Now our weather, it will be warm. It may feel cool because we're comparing it retroactively to how hot it was before, but the weather will probably be very similar to the way it was on the first day of spring. Now it may actually feel warmer for us, and temperature-wise, if we went back and compare the first day of spring to first day of fall, temperature-wise may be warmer. That doesn't have to do with anything to do with insolation. Insolation is going to be very similar on the first day of spring and the first day of fall. However, first day of fall, for the past 3 months, we've had really, really high insolation, and that all of that solar energy has been baking down into the ground here, baking down into the earth, and the earth is just absorbing it and absorbing it and absorbing it and absorbing it. And it's holding on to it, and it's holding on to it, and it's holding on to it. And even though we're not getting as much insolation as we were before, the earth still has an excess of it. So it's still radiating some of that heat back. And because of that, temperature-wise, it'll stay warm well into the fall here because the earth has been, it's like a bank account. We've been making deposits of this heat energy, and we use some of it every day. But because we had an excess of it, we still feel that as warm days. Let's go look at these things for winter. On the first day of winter, the solar declination is the Tropic of Capricorn, which is 23.5 degrees south. Now that's as far away from us as the solar declination will be. That is as far as it will get. Okay? Let's go to the calculator and look at our solar angle. And all we have to do is change this to December. And we're going to execute that. Our elevation is 36.5. So if we just look at these numbers, this is the lowest number. You see that it's not a straight line, is it? The difference between summer and the first day of fall and September, or first day of fall and first day of spring, are much different than the first day of winter in those 2 days, right? But the lowest day of the year is this first day of winter. So the sun doesn't get very high up in the sky. How many hours of daylight do we have? Well, we have less than 12. I'm just going to estimate it's about 10.5 hours. And it's cool, because I know some Texans think it gets cold here, but it doesn't get cold here. I moved here from New York, and let me tell you, it doesn't get cold here. On the first day of winter where I lived in New York, when I did this, the solar declination was exactly the same. The solar angle for us was like 13. It was so depressing to live there because it was dark. There were so few hours of daylight. There were only 9 hours of daylight. The sun barely came up in the sky. It was really, really depressing. So our insolation is the lowest it will be all year. Now, our insolation on this day is still much higher than it was where we lived in New York. The insolation there was much lower, and that obviously is represented by the fact that it's still warmer here on the first day of winter than it is in a lot of those places. Okay, so if we understand these things, okay, if we know where these things are on the first day of each season, where this becomes useful is if we can then spread these days apart and say, okay, what would if the first day of spring is March 22nd, the first day of summer is June 22nd, what would this be on April 1st? What would this be on May 15th? And you can estimate that, right? Because on April 1st, the solar declination, we can just estimate it, but it has to be somewhere between the equator and 23.5 degrees to the north. It has to be. Solar angle has to be somewhere between 43 and 80. Daylight hours has to be somewhere between 12 and 14. So we can use these to estimate. I recommend that you make yourself a chart like this. My guess is that you would see something like this on the quiz over this, because it's important to understand. I'm going to stop there, and we will see you next time.